Hi class, this is Mr. Scrunchy here. This is the first day of notes. This unit is called Introduction to Geometry, and topic 1 is definitions and notation. So geometry has a lot of vocabulary in it, probably a little bit more than algebra, and a special notation. A lot of times in algebra, you're just dealing with x's and y's and this and that. We have to be careful how we write things in geometry. We're going to work on how we're going to write like lines and segments and this and that, and so notation is very important in this geometry course, and you'll see this as we go along. Okay, next page. So what makes up geometry? So the first thing we're going to look at is a point. A point is just a location. It has no size or shape. Technically, it has no dimension at all. You couldn't really see a point. Now we make it a big thing here like this, so we can actually see it when we do math or geometry, but technically a dot is non-dimensional. It's really not really, it's something you can't really see. And our notation for a point is a capital letter. So this example, this is point A. I could draw another, and over here, and that would be point B, and so on and so forth. So the next thing we're going to look at is a line. A line is made up of many points. In fact, an infinite number of points are on a line. Okay? But if you want to draw a line, all you need is 2 points to draw it. In this case, we have points x's and y's to draw this line. So a line has no thickness or no width. It has only one dimension. And when I say thickness, I mean it has no depth. So a line is just a one-dimensional figure that has nothing much you can see. Now, when we name a line, we could use 2 points on a line to name it. So for this example, I have these 2 points, and I could call it x, y, and I could put this little top hat on it. Now, the order doesn't matter when you do a line because I could call it yx. So when I talked about notation, it is important to recognize that when I put xy with that special notation on top, the line notation with the arrows pointing in both directions, or yx with the line on top with the arrows pointing in both directions, this means it is a line that goes on forever. We also could have called it this lowercase line n, kind of like a script n. And in this example, all 3 of these things represent the same thing. And lines extend forever in both directions. They do not stop. Another special word, collinear, points that are on the same line. So point x's and y are collinear. If I do another line, let's call it WZ, I could call it line WZ like this. WZ would be collinear. 2 points will always be collinear, but if you wanted non-collinear points, you had to name at least 3. So you could say X, W, Z are not collinear. Even though WZ are collinear, X does not. So 2 points, always collinear. 3 points may or may not be. Okay, the next thing we're going to look at is a plane. A plane is a flat surface. Kind of like a piece of paper. Not exactly, because a piece of paper does have thickness to it. A plane technically does not. A plane is only 2 dimensions. Length and width. No real depth. A piece of paper would have a slight piece of depth. And to name a plane, we use any 3 points on a plane. And not only look, if you look here, if you look at this plane over here on the side, I'm kind of over here on the side that I'm kind of circling in the purple here. This plane doesn't end like a sheet of paper. It goes on forever in all directions. So when I want to name a plane, I use the letters. So I could call it plane. Any 3 letters on here. J, K, L. It doesn't have to be in order. I could call it plane J, P, K. Whatever you want to call it. They're all the same. Or because we have this capital letter right here, I could call it plane. Kind of the script P. So coplanar points are points that lie in the same plane, and it always has to be 3 points. 3 points. If you name 3 points, they're always are coplanar. And non-coplanar points would be points that are not. So that would have to be at least 4. So let's look at intersecting things. So first of all, we have line R and line S, and they come together and they intersect in a point. So line R and line S intersect at point capital P. And when I have 2 planes intersect, it's kind of like 2 pieces of paper hitting each other. When they intersect at a line. Plane, this L, and plane M intersect at line K. So let's try to answer some of these questions. 4 collinear points mean they have to be on the same line. And 4 collinear points, well, it can't be this point here, it can't be this one, it's got to be the one that's going up and down. H, N, K, I are collinear. So I need a line that contains point M. Well, right here is point M, and this line here I could call it line P. I could call it line MN with a little line head on top, or technically I could do this. We'll do this in very light yellow. Here is, even though it wasn't drawn, I could have said line MK because even though it wasn't drawn, I could take any 2 points and make it into a line. Let me grab red. A line that combines H and K. Well, right here, here's point H, here's point K, and that could be, you could call it line R. You could call it NK. You could call it HI. Many different names. Here is line Q. I could call that JK. I could call it line KL. I could call it many different things. They're all the same. And then it asks, where do P and R intersect? So here's P here, here's R here, and they intersect at point N. So now we're going to use this diagram that has that flat surface, plane R on the bottom, and this pyramid on top of it. So name 3 coplanar points. Well, I could just name any 3 points on plane R, which would be V, W, X. Those are on plane R, but technically I could just name any 3 points. Doesn't matter. Any 3 points would make a plane. I could have done X, Y, and Z. X, Y, and Z, they're kind of the back side of that pyramid. So a plane that has point X is right here. So I could call that plane R if I want. But there's many different planes. I could call it plane, again, X, Y, Z, that back side. It goes out forever, but that is a plane. So the intersection of plane R and Z, V, Y, well, plane R is this bottom one, and Z, V, Y is right here, and that would be line V, Y. So how many planes appear in this figure? Well, I would say the one R here, I'll use this one. So this one R on the bottom here, and then this side face of the pyramid, this front face of the pyramid, this side face here on the left, and the one all the way here in the back. It looks like maybe there's 5 planes. And how many planes contain point W? So I'm actually going to erase some of this. And here's point W right here. And obviously it's on plane R, but it's also on this plane right here, this side face, WXZ, and it's also on this front face, WVZ. So I'd say it's on 3 different planes. Okay, so they say, next one, what is the intersection of L and M? Well, L is here and M is here, and they intersect right here at point E. Plane Q is right here, and I can use any 3 points I want, but I cannot use F, E, G because those are collinear. I need 3 points that are not collinear, so I can use plane F, G, I, or plane E, I, G. There's just many ways to do it. Are point D and E collinear or coplanar? Well, D and E, here's D, here's E. They're definitely on the same line. It's definitely collinear, but if you're on the same line, you also are coplanar. You could not exist on a line and not be on the same plane. How many times do planes P and Q intersect? So they're like this here. And the idea is that, well, do they intersect? It's so hard to tell, but from our point of view, and we're going to see a lot more of this with lines, but planes could be the same thing. They intersect 0 times. They are parallel planes. Okay, more notation, more vocabulary. We're going to talk about things called line segments. A line segment consists of 2 endpoints. A little bit different. A line does not have endpoints. It has got points on it, but they don't end. They go on forever. So it has 2 endpoints and all the points in between. So technically on this line segment here with endpoints A and endpoints B, it has an infinite number of points on it, but we really make note of the beginning and or the 2 endpoints A and B. So these endpoints are the end of the segment. Okay, now this is a little mistake here. It says name a plane. It should be name a segment. You're going to have to cross this off your notes using the 2 endpoints in either order. So here's the idea. When you call this is again where notation matters. Over here on the right here, it's segment AB. So it's AB with just this flat line with no arrows on it. Or I can call it BA like that. It doesn't matter. It's the same segment. No arrows. If you put arrows on it, it would represent a line. This is a line segment that has endpoints. The next idea is something that's called a ray. So a ray is a portion of a line that has an endpoint and goes off in a particular direction to infinity. So it starts at some endpoints and just goes on forever. So a line is something that goes on forever in both directions. A ray goes on forever in one direction. So whenever we name a ray, we start with the endpoint first, and then any other point that's on the ray. So for this example up here, I'll circle it a little in red. This is ray A, B. This one I'll do in blue. This is ray B, A. Ray AB starts at point A, goes through B, and goes on forever. BA starts at B, goes through point A, and goes on forever. Okay, one-sided arrow. Okay, so the arrow is the direction. And then we can look at this. This is the endpoint. And this is not the same as ray AB. I'm going to write this in purple. Order matters. Okay? In fact, these 2 things are going in the opposite direction. So let's talk about the difference when we use this little top symbols on top of letters. So a line, I put AB with that's a line symbol. That means it goes on forever in both directions. That's what happens with a line. The next one, let's call it segment. Segment AB has 2 endpoints. It means it begins at A and stops at B or vice versa. It doesn't matter the order. But then finally, when we get to ray AB, that means it starts at point A and goes forever in direction of B. Okay, so a line and an array do go on forever. A segment has two endpoints. So let's talk about some distances and how we measure distance. So the distance between 2 points, let's say between 2 points A and B, is the line segment, and we call it, in words, the length of line segment AB, and we write it as AB, and there is no top symbol on it. So when you put a top symbol, when you put a top symbol around something, that means it's a line segment. With nothing, it just means is the length of that line segment. And for this example, well, this goes from -1 to 3. That length is 4. Now, if we look over here, this was 4, and over here, so if AB, which is 4, equals CD, that means they have the same length. That means they have equal length. Okay, but those AB and CD with no top symbol means they're lengths. But then we want to talk about how these segments are the same length. And we use something called congruent. So when we talk about segment AB and segment CD, you see now they're not lengths anymore, they're segments. It has a little top symbol to indicate that. We can't put an equal sign in there. When we talk about something geometric that are the same size or the same length, we do an equal sign with a little squiggly on top, and that stands for congruent. It's very special. So segments are congruent while the lengths are equal. So let's talk about how things make sense. Well, I have over here segment AB, segment BC, and the whole thing is segment AC. So very simple segment addition. The length of AB plus the length of BC is equal to the total length of AC. Okay? Very, very simple thing to do. Simple algebraic concept. So I'm going to use that idea for these questions. Well, I know that PQ plus QR is equal to PR by my segment addition. Well, I've given some information. PQ is 9, QR is 28, so 9 plus QR is equal to 28. Oops, I made a mistake. I got to pay attention. Let's try that again. 9, PQ is 9 plus QR, which is 28, and that is equal to PR, and that means PR is equal to 37. As opposed to, well, let's see, I don't know what PQ is, so PQ plus QR, which is 17, is equal to PR, which is 21, and by simple algebra, PQ is equal to 4. I think you could do those pretty simply. Okay, let's see if you get these two by yourself. Well, let me set it up for you, first of all. So I know given TU plus UV is equal to TV. Well, let's see, what do I know? I know TU is equal to 9x plus 2. UV is 5, but I'm given here at the top 14x minus 8 is the length of the whole long segment. I'm going to use my basic Algebra 1 skills. 9x plus 7 is equal to 14x minus 8. I'm going to bring the 9x over. I'm going to bring the 8 over. And I get, well, if I bring the 9x over by subtracting, I get 5x. If I bring the 8 over by adding it, I get 15. I get x is equal to 3. But that's not really the question. The question is, how long is TU? Well, TU is that, 9x plus 2. So TU is equal to 9 times 3 plus 2. So TU is 27 plus 2 is 29. Got to make sure I answer the question that's being asked. Let's see if we can, if you can do this one on your own. We'll set it up to begin with. JK plus KL is equal to JL. And what do we know? We know that JK is 27 plus KL is 3x minus 1 is equal to 5x plus 2. So I'll let you do the rest on your own, and I'll put the video back on. So finishing off the rest of the problem using my algebra skills, you can see that I was able to solve for x is 12 and plug it back in and get JL equals 62. On the next page, I want you to do those problems on your own and come back to the video and see how you did. So you can see in number 5, I set it up by doing my segment addition, putting in the variables, and this one was easy. All I had to do was solve for x equals 5. This next one, I'm going to do a little bit more work. Not only do we have to solve for x, we have to solve for all parts of this segment, finding each value, and SY was a little bit tricky, 36 minus x. So I set it up, solve for x, got x equals 2. I plugged 2 into the SK part, I got 21. I plus 2 into the KY part, I got 13. So 21 plus 13 is going to be 34. But I could plug it into the SY equation, that tricky one. 36 minus 2, and I guess what? I still get 34. It worked out either way. Okay, I told you there's a lot of vocabulary in geometry, and here's another piece of vocabulary, a midpoint of a segment. So a midpoint of a segment is a point that divides the segment into two congruent segments. So looking at this picture here, see these little tick marks? These little tick marks right here, they indicate that AB, the length of AB is equal to the length of BC. Because they're one tick mark here, one tick mark there. That means they're exactly the same. So two congruent segments are two segments that have the same length. Okay? A line, ray, or segment that intersects it. So you don't have to have just a midpoint. A line, array, or segment can take a segment and make it a midpoint. Is said to bisect it. That means it cuts it in half. Okay? In this case, we have this line L that does some of that. It cuts it right in half. And that is called a segment bisector. It cuts it in half. So on this diagram on the left, point B is the midpoint of that segment AC, and line L is the segment bisector of that segment AC. Okay? Doesn't have to cut it at a certain way, just has to go through the middle. You could trisect a line and do all that, or segment and do this and that, but we don't do that too often. We usually talk about segment bisectors. So here's an interesting question. Does a line have a midpoint. Does array have a midpoint? Can you bisect them? Interesting question. So here are some examples that use this idea of a midpoint and having bisecting a segment and having two congruent segments, or these little ticks. So since PQ is going to equal QR, because Q is the midpoint, I have to solve for x. I get 7x minus 16 is equal to 4x plus 2. I'll show some algebra here. I'll subtract the 4x. I'll add the 16. I get 3x is equal to 18, or x is equal to 6. Ooh, where did I go wrong? Oh, x is equal to 6. I'm right. Okay. The next one, r is in the middle, so QR is equal to RS. So I get 2x plus 16 is equal to 5x minus 17. And I'm going to move things around a little bit. I'm going to bring this 2x over. I'm going to add the 17. I get 33 equals 3x, or x equals 11, which is not what I'm looking for. I'm looking for QS. So QS is this whole thing. So I have to plug in 11 here. So QR is 2 times 11 plus 16, which is 38. And guess what? RS better be the same. I mean, it's a bisector. It better be the same, but I'm going to check anyways. 5 times 11 is 55 minus 17 is also 38. So when I want to do QS, I'm going to change color here. QR plus RS is equal to QS. So 38 plus 38 is equal to 76, and that is how long QS is, or twice as long as one of those segments. So for this one, I know FG is equal to GH. So 4x plus 3 is equal to 7x minus 12. Do some fancy algebra by subtraction of the 4x and adding the 12. And I get 15 is equal to 3x, or x is equal to 5. But then I have to find y. So the way I set that up is I got to plug in for FG. So FG is equal to 4 times 5 plus 3, which is 23. And GH better be the same, but I'm going to check anyways. 7 times 5 minus 12 is 35 minus 12 is also 23. So FG plus GH is equal to FH. So 23 plus 23 is equal to 46, which is equal to FH. And that is just 6y, excuse me here, minus 2. I'm going to add the 2. I get 48 is equal to 6y, or in the end I get y is equal to 8. That was a lot of work on that problem, but it's all doable. Okay, these next 3 pages are examples for you to work on. I'm just going to pause the video and do them, and then I'll bring the video back page by page, and you can see what's going on. Please ask questions if you don't understand. Realize sometimes there's more than just what my responses to these questions, as if it says the line containing point F, there's many answers to that. So give it a try, ask questions, and hopefully everything will go well. So here are the results for this first page. Pause the video and look at it. And here are the results for page 2. Pretty basic, not too bad. And here are the solutions to the last page. Check them over, ask questions. This first video was a little bit long, 35 minutes. They won't be this long anymore. It's just that a lot of notation, a lot of definitions, a lot of symbols. Thank you for watching, and hope everything goes well.